Professor Dave here. Let's talk about phase changes.
He knows a lot about the science stuff. Professor Dave explains.
It's possible for matter to transform directly between any of the three phases. We are probably aware of melting and freezing, which go between solids and liquids, as well as boiling and condensing, which go between liquid and gas. In addition, going directly from solid to gas, like dry ice, is called sublimation. Going directly from gas to solid is called deposition. Each process carries with it a particular change in enthalpy. Any liquid will have a vapor pressure, as some particles will spontaneously evaporate, and as the temperature is raised, the liquid will eventually reach its boiling point, which is where the vapor pressure is equal to the atmospheric pressure. At this temperature, bubbles of gas will form within the liquid, as opposed to only molecules at the liquid-gas interface going into the gas phase. The normal boiling point of a liquid is measured at 1 atmosphere, or the pressure at sea level. When atmospheric pressure decreases, the boiling point decreases, which is why water boils at a lower temperature at higher altitudes. The freezing point of a substance is the temperature at which a liquid turns to crystalline solid. The melting point is the temperature at which a crystalline solid melts. These are the same temperature, they just represent processes in opposite directions. As we heat a sample of ice, it will melt and then boil. On this diagram, the flat sections represent the phase changes themselves. In these sections, the temperature doesn't rise because the heat energy being added is going towards disrupting the lattice energy of ice or overwhelming the hydrogen bonds occurring in liquid water. So, during these periods, the heat energy does not go towards heating the sample. Once a phase change is complete, the heat energy returns to heating the sample. The energy exchanged during melting and boiling is called the heat of fusion and the heat of vaporization, respectively. The phase change is denoted by these subscripts, telling us when water is considered solid, liquid, or gas, and this is the energy needed per mole of water to cause the phase change. This is specific to water because every compound has a different lattice energy in the solid phase and makes intermolecular contacts of differing strength in the liquid phase. Phase diagrams show what phase a substance will be in at a particular temperature and pressure. For water, we can see the phases we would expect at atmospheric pressure. If the pressure is dramatically lowered, we can see how water would sublimate as the temperature increases instead of melting first. On a phase diagram, lines represent equilibria between two phases, and the triple point represents an equilibrium between all three. For water, the line between solid and liquid slants up and left because the solid form is less dense than the liquid form. For carbon dioxide, it is the liquid form that is less dense, so the line slants up and right. Also notice that at atmospheric pressure, carbon dioxide is never a liquid. This is why dry ice, which is solid carbon dioxide, typically sublimates. Let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials, and as always, feel free to email me, ProfessorDaveExplains@gmail.com.